In the context of atomic structure, shells and orbits are terms often used to describe the organization of electrons around the nucleus of an atom. These terms are related but have distinct meanings. Shells' energy levels. Definition. Shells are the main energy levels or electron energy states within an atom. They are designated by whole numbers, typically represented as N, where Na 1, 2, 3, 4, and so on. Each shell corresponds to a specific energy level at which electrons can exist in an atom. Electron capacity. Each shell can hold a specific maximum number of electrons, determined by the formula 2d, where N is the shell number. For example, the first shell HNCN can hold a maximum of 2 electrons. The second shell TNCRe can hold a maximum of 18 electrons, and so on. Proximity to the nucleus. Shells closer to the nucleus have lower energy levels, while those farther from the nucleus have higher energy levels. Electrons in inner shells have lower energy than electrons in outer shells. Electron distribution. Electrons are distributed among the shells in a specific order following the Ophiuhpo principle, which states that electrons fill the lowest energy shells first before moving to higher energy ones. Orbits by model. Definition. Orbits refer to the specific circular paths or trajectories that electrons were originally thought to follow in Niels Bohr's early atomic model. In the Bohr model, electrons were assumed to move in fixed, discrete orbits around the nucleus, similar to the way planets orbit the Sun. Quantization of angular momentum. In the Bohr model, the angular momentum of electrons in these orbits was quantized, meaning that it could only take specific, quantized values. This concept was an attempt to explain the stability of atoms. Limitations. While the Bohr model was groundbreaking and provided a useful framework for understanding atomic spectra, it had limitations. It could explain the spectra of hydrogen and hydrogen-like ions, but could not accurately describe more complex multi-electron atoms. Modern quantum mechanics, with its wave functions and electron probability distributions, replaced the concept of fixed orbits with a more probabilistic description of electron positions. In summary, shells refer to the energy levels or electron configurations within an atom, while orbits were a concept in the early Bohr model that described the paths of electrons around the nucleus. The Bohr model's concept of fixed orbits was eventually replaced by quantum mechanics, which introduced a more sophisticated and accurate understanding of electron behavior in atoms based on wave functions and probability distributions